Hello friends, this video on alcohol phenol ether part 20 is brought to you by examfear.com. No more fear from exam. Talk about phenols. We have discussed what is phenol. We'll discuss the preparation of phenol. Right? So phenols are also called carbolic acid. Please note, it is called carbolic acid also. Why? Because it was first isolated from coal tar. Correct? Since it was first isolated from coal tar very early 19th century, from coal tar, it's called carbolic acid. Please remember this. Also, it is more acidic than alcohol. It is in fact more acidic than water also, and we'll tell you why. So we'll first talk about the preparation of phenol from haloarenes, from benzenesulphonic acid, from diazonium salts, from cumene, from Grignard reagent, and from phenolic acid. We'll try to prepare phenol from all these. The first is from haloarene. So we'll see this reaction from haloarenes and aryl sulphonates. Let's see the aryl sulphonates first. This is my aryl sulphonate, SO3Na. From this I have to form phenol. So what I do is I add NOH minus. So OH minus is a very strong nucleophile. It will replace SO3 minus. So it's a substitution reaction actually. You get OH plus Na2SO3. Pretty easy reaction mechanism actually, so I will not discuss this. Here also from haloarenes, so let's take this chlorobenzene. This also you add this NOH and the temperature has to be good. Right, so in this case also what will happen is this OH minus, right, strong nucleophile will replace this chlorine. So we get NaC. The second is from benzenesulphonic acid. So I have benzenesulphonic acid, SO3H, same thing, I have NaOH, it's a very strong nucleophile, it replaces SO3H, it will give me OH, this is phenol. The next is from diazonium salt, using steam distillation. So we have this salt, diazonium salt. What we do is we take this water, we heat it, and we get phenol. I'll show you the reaction. I have this diazonium salt, this N2Cl, and you take this water, you heat this, you get phenol. Plus nitrogen comes out and you get HCl. Right? So here also carbocations are formed. And this is called benzene diazonium chloride. Benzene diazonium chloride. Correct? The question is how to form this diazonium salt. So what you can do is you have this this compound can react with NaNO2 with some acid, you get this compound N2Cl. It's plus, this is minus. It's not difficult. From diazonium salt you can just put some water and heat it up a little bit, you get phenol. The next is from cumene. See, this is cumene actually. This is cumene. The common name is cumene. The common name is also isopropyl benzene. Isopropyl benzene. And the IUPAC name is 2-phenyl propane. Right here. IUPAC is 2-phenyl propane. The common name is cumene or isopropyl benzene. Very critical compound, and when you oxidize this, it is oxidized to cumene hyperoxide, and then you can convert this to phenol by reacting it with dilute sulfuric acid. Let's see this reaction a little complex, so but just please pay attention here, you will understand this. So I have this cumene here. In fact, We draw it a little clearly. CH, CH3, CH3. Right? This, due to double bond, right? This is the electron rich carbon. This carbon is electron rich carbon. Right? Phenol is also giving electrons, so these groups are also giving electrons. This carbon is electron rich carbon. Right? So when it is oxidized, the electron rich carbon is oxidized. So the CH becomes COH. So if you see this reaction after oxidation, this is something like this. CH3, so the carbon here, COH, and this is CH3. Correct, because this was the electron rich carbon, so it got oxidized. You got something like this. On this, you add H plus. H plus will attack this oxygen here. In fact, oxygen will attack this H plus because it has lone pair of electrons, and this is electron hungry. So what you get is something like this. C, CH3, CH3, C, O, O. Now here, this oxygen will get a positive charge. So why will oxygen get positive charge? Because oxygen is giving lone pair to this hydrogen. So it will get positive charge. Now this is a good leaving group. If it leaves, this gets a positive charge. But that is not good, right? Oxygen to have positive charge. So what will happen is, this will leave, and at the same time, this carbon, instead of forming bond with this, it will form a new bond with this oxygen. Please understand, if H2O plus is a good leaving group, but if it leaves, if the oxygen gets a positive charge, that is not good. Oxygen is the electronegative element and it doesn't want a positive charge. So this carbon will form a bond with this oxygen. So, and this H2O will go off. So with this, the product you will get is this carbon will form a bond with this oxygen and this carbon, right? Correct? In fact, this is the case here. Yeah. This carbon and this carbon has 2 CH3. And now since this bond broke into this fashion, this is negative, this is positive, this carbon made a positive charge. Hope you understand. This bond broke in this fashion. This gets negative, this gets positive, this negative and positive forms a bond, and this positive comes in this carbon. Correct? Now I have to what? I have to add a OH minus to neutralize it. So I'll just add a OH minus here. Correct. So what with this you get is this compound. Let me draw it here. O, C with OH here, CH3 here and CH3. Correct. Now what will happen is this oxygen has a lone pair. Correct. Now if H plus attacks this guy, it will form a bond with HOH and it will kick out this guy. So if you see, it forms a bond with O and it will kick out this. Correct. So what will happen now is it will form something like this, OH, and this is kicked out now. Right? The way it is kicked out is this becomes minus, this becomes plus. This bond breaks in this fashion. Plus C plus CH3, CH3, OH. And now this is the plus here, and this carbon has a plus charge. This H will say, okay, I'll get rid of this. So it will be double bond formed here, right? This bond breaks, H plus minus, minus plus forms a bond. So with this phenol is something you have already got, and this becomes ketone. This is acetone actually. Correct. So this is my output. Hope you understand. See, this part was simple. This part was simple, right? From here, this part is a little complex where carbon now forms bond with this oxygen. So once that is clear, things are not that difficult. Correct. Now the question is how to get cumene. Since we are using cumene, we should know how to make cumene, right? So let me draw a line. What you can do is you can take a benzene and you can add this propene, right, in presence of some acid, maybe S3PO4, you will get cumene. CH3, CH3. Yes, this is what you'll get. It's pretty easy reaction actually. Correct. So what will happen? It will form a carbocation. This will be positive and this will be negative according to Markovnikov rule. Correct. And this will get attached here. Hydrogen will be kicked out and this negative charge and this will be formed and that will come here. So it's an easy reaction. Now we'll see the preparation of phenol from Grignard reagent. In fact, not very difficult. What we can do is I can have a Grignard reagent which has a benzene attached, MgBr. This guy I can react with oxygen in presence of light. This will give me O2 MgBr. And then you can add water to it. It gives you OH. Pretty easy reaction. Now I'll try to prepare phenol from phenolic acid. So what we can do is we can do a distillation with soda lime here. This is my phenolic acid. Please see. COO Na. Yes, this is my phenolic acid. What I can do is I can react with NaOH and CO with soda lime. What I get is ONA. And this I can just react with H plus in the acid. I get OH. Correct. This is the way to prepare phenol from phenolic acid. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.